Greetings, this is Artie from Artifact Electronics. Thanks for joining. So today, this just came up. I'm going to deal with a more practical problem that I ran into. You're looking at one of my main computer monitors, and what this guy started to do over the past few weeks, it'll just randomly, the screen will go blank, and then it'll come back again after 2 seconds. Sometimes it'll do it once and then stay good. Sometimes it'll go into a cycle and do it 3 or 4 times and then come back again. And yes, it's a rather annoying problem. I have 2 of these monitors on my machine, identical. I took out all the cables and blasted dust out of them, rebooted Windows a couple of times to see if this was a driver problem, but it would fix it. And then today it actually went into a really bad cycle where it was where the thing was turning on and off periodically, in a matter of a second or 2, just oscillating on and off, which generally is an indicator of a switching power supply going bad. It wants to start up. It does start up briefly, and then it goes cockeye again. So I did go ahead, since I have 2 identical monitors, and I switched the power supply on them. And guess what? The problem moved with the power supply to the other monitor. So, of course, it's not doing it now. I can go ahead and turn this thing on. And as you can see from the blue power light, it actually comes on and goes into its little demo loop. And I mean, everything works. Everything works just great. But I know that the minute I put this thing back, plug it back into my computer, it's going to start acting up again. So I thought I'd take apart the power supply and look for some obvious problems in here, bad caps, burnt parts, and that sort of stuff. Now, this is, of course, a sealed power supply, so I'm going to have to cut it open. I don't have a replacement for it because it's a little oddball. It's 14 volts at 2.5 amps. And I have a 16 volt, but let's not aggravate the situation here by overvoltaging it. So let's go ahead and see if we can cut this guy open and see what's on the inside. So let's get out the trusty Dremel with a cutting disc on it and see if we can cut along the seam on the sides here. You've got to run this at as slowly, as it'll still work. Oh yeah, noise alert, but otherwise it'll just melt the plastic on the side of the case. So just have it as low as I can. So you get the idea. I'm going to do this off camera. I had to turn it up to speed 3 because it was getting bogged down at lower speeds. So let me see if I can open this thing up. It is melting plastic a little bit at that speed, but I guess that's just the way it is. So we'll come back when this case is open. Okay, it's never going to be pretty again, but we got through. You can see some metal shining through, and basically cut as close to the connector as I could, and the output cable. So there you go. And the whole thing should just lift out. Okay, remember, this is the bottom. And here's our power supply. I don't see any burn marks on here. And there's a big cap here, 2 smaller caps over here on the output side, those wouldn't affect the switcher. This wouldn't make the switcher turn on and off. This just to smooth the voltage coming out. Because here's the input transformer, then we have the oscillator in the middle, and then the output transformer over here, and of course these smoothing caps. And this is the main cap that keeps it oscillating. So if anything went bad, or is going bad, it would probably be this. So let's see if we can measure this in circuit. I mean, I was going to say let's look for leaks, but it's been gooped very well, so I can't see anything at all. And really not that much in there. So let's get out the meter and see if we can measure caps. Well, let's go and measure some capacitances. But first, with these peak instruments, you have to be very careful that there's no charge on the caps you're measuring, because I've lost some of these plainly because it's unable to discharge the caps, even though it claims that it discharges them. I don't know what the limit is, but that limit can be reached very quickly, and if there's a significant charge on the cap, it'll blow this meter right out of the water. So just short the terminals, which you can't see, which I'm hiding of course, but you identify the terminals and you just touch them together. And we're just going to look at the electrolytics in there. There's two of these over here in parallel. So everything seems to be discharged. So let us see. I can do this without completely obscuring it, but 75 microfarads and an ESR of 0.36 ohms. So that seems good. It's listed at 82 microfarads, 105 degrees rated, 450 volts. So that one seems okay. So let's go in and measure these two guys that are in parallel. And it's giving us parallel reading. I mean, the ESR is well within limits, 0.09. Oh, I just moved the terminals here. Taking it a while. Oh, C not measured. So these are the output smoothing caps, and it's being unhappy about them. And now it tells us that there are approximately 1500 microfarads. That seems a bit large, don't you think? Let's see what they're labeled as. Of course, they're mounted in a way where I can't read their values properly. So let me go ahead and pull these two out and measure them out of circuit. Not that hard to do. A little bit of goop over here, but they should be easily accessible. And see what they measure out of circuit. So I removed both of these. Actually, if I looked at it at just the right angle from over here, I could see what their values were, but I thought I'd take them out anyway. And I guess they measured okay, because they're 680 microfarads at 25 volts. Let's measure them once more anyway. Stay. If we can get this to be more visible. There you go. So here's number 1. Measures at 721. Yeah. 724. So they actually measure good, but one thing I did notice was, I don't know if you can see this, but I cut into one of them when I was opening the case. Now I haven't cut all the way through, it's just metal that's showing, but I'm not going to reuse this. I'm going to replace the caps in here. Of course I don't have direct replacements, but what I do have is 1000 microfarads at 25 volts. So I'm going to put 2 of these in there. This will just smooth the output a little bit better for us. And I can't see anything else wrong, and then basically hook it back up again, let it sit on the bench for a while, and see if it still turns on and off. I'll probably also clean up the case, the edges of the case a little bit, so and get all the plastic pieces off and put it back together and put it back to where it belongs. Not a very satisfactory result here, because I didn't find anything directly wrong with it, and it doesn't do it all the time, but maybe I can just run it on the bench for a while, and if it starts doing it again, start cold spraying this and see if that would aggravate the problem. I ran this monitor on the bench for about 2 hours. Yes, there's no real signal going into it, but it basically keeps complaining about alright, there's no signal input, blah blah blah, and then after a few minutes it'll go into saver mode, which is indicated by the screen going blank, but the blue power light's still blinking. And then you hit any front panel button, the power light goes on solid, and the little complaint comes back up on the screen. So after resoldering some more connections and just having another look at the board, I couldn't see anything. So I went ahead, left it open frame, and hooked it up to the computer and worked on it for about an hour, and it worked flawlessly. So I guess there's not much left other than putting it back together again and see if I hit that bad connection or the output caps were actually causing a problem. But I need a bit of a visual indicator of what the power supply itself is doing. So now is the time to do some redneck engineering on this. And what I found was the board actually has provision for a power LED. As you can see, there's these 2 through holes, ground, and the positive side of the LED. Then there's a limiting resistor placed here that isn't, of course, has nothing in it, and a jumper running from here over to here, which is the positive output. So if the jumper, which isn't installed on the other side, the resistor and the LED were installed, then you could actually see what the supply is doing. And if the monitor starts flashing on and off, you could look at that LED and figure out if it was actually the supply going down, or if or if it got the LED gets dim or whatever. It gives you a bit of an indication of what's happening for you to do fault isolation. Now the biggest problem for me was that when doing this, I got to drill a hole in the case, and how do I know where to drill the hole in the case? So what I did here was essentially approximately somewhere over there, disregard that X for now, that came later, but I drew a freehand grid on that. Then put the LED into the PCB and reinserted the PCB into the case. And of course, let's see, ground is on the outside. Did I not remove the solder from this thing? Thought I did. There you go. And then we reinsert the PCB into the case, straighten out the LED pins, you know, best as we can. Make sure not to move anything, and then shine a light into it, and using the grid as a guide, which I can't really show because if I move this then it's going to move. Actually it shows up from the side too, but putting this in here and seeing approximately where it hits the grid, and then mark the grid, and that's where we drill for a hole for the LED to peek through. So this is where the real part of the redneck engineering comes in. So I drilled a hole in the case that was slightly smaller in diameter than the LED because I don't want it to go through all the way and stick out, just a little bit of it. And that fit in. And then I put the limiting resistor directly from the output to the positive side of the LED. And since the LED is being properly held in place now, at least I hope so, we can solder it in. Make sure that the resistor isn't touching anything else. And looks good. We can see the resistor, which is just kind of poking out of here, and that'll tell us what's happening. So let's go ahead, button it up, and see what we got. And of course, let's not forget to cut the leads off of the LED. And that should be it. And there it is. Covered up the sides, so looks good as new. The seams were actually kind of big in there. I think the cutting disc I used was too thick. So use a thin cutting disc, but that'll hold it together. And it will indicate to us clearly what power supply is doing. Yeah, it's a bit bright, but I did that on purpose because I basically have all of this stuff sitting under my desk in a mess of cables, and this will cut right through that clutter, and if the monitor acts up, all I got to do is glance down and I'll know pretty quickly what's happening. So let's put it back onto the computer and see if it's going to do its job. Well, so far so good. They're both running, they both came up, and Windows is aware of both monitors. So I'm not going to sign off from this episode yet. I'm going to test this for a couple of days. So spending a few hours working the computer and seeing if it hiccups at any point in time. You can see the bright blue light there. Yeah, it's a bit bright, and for those of you who want to know, I used a 2K resistor for the limiting resistor, but this thing is going to go get off the top of the computer, hide on the ground behind it somewhere, but that brightness is going to allow me to monitor it if the monitor hiccups again. So we'll see you in a few days. And here we are several days later. I've used the machine pretty heavily, and it did not hiccup once. Now, it could have hiccup while I left the room, but I'm too lazy to put a data logger on here to find out what's happening. It's never happened while I was on the computer. So if it wants to do it while I'm out of the room, be my guest. But it didn't do it while I was looking at it. So the repair was successful. Now, in conclusion, generally if something like this happens, I will not spend the time to fix a power supply that I can pick up pretty quickly. Even though this was a bit oddball, I'd have to order it off eBay from a US seller, wait 2 or 3 days, and when this happened, I had to get a lot of work done for the next day. So basically, I could have worked with a single monitor, but hey, it was more fun to try to fix that supply rather than do work on a single monitor. So we are done. Final analysis on it. How did it get fixed? Well, it got fixed by exchanging the output smoothing capacitors, which doesn't really make a lot of sense to me why that fixed it. Even though the secondary transformer has a feedback winding, and maybe something was going bad on that, and that was causing the switching part not to work properly. Or what I just realized was I've put an LED across the output. Could that have anything to do with it? I'd welcome your comments on that. And I'll probably go ahead and order a replacement power supply for it anyway in case it does it again. But if you think I did good, give me a thumbs up. Make sure to subscribe. And I'm going to have something next time a lot more interesting than this for you. So stay tuned. See you later. I couldn't help myself. I had to do a quick teaser for the next episode. So what you're looking at is probably the largest diode I have in my lab. And for size comparison, here's a 1 in 4001. So this thing looks like a squat spark plug, and I'm sure it could do a lot of damage. So make sure to look for the next episode, and you'll find out what this is housed in.